Right, hi there. Welcome to the last lesson on trig graphs. What we're going to look at today is what happens when we put an adder or a subtract inside the bracket this time alongside the x. Okay, so our learning intention today is being able to sketch graphs where this occurs and describe the amplitude period and set the maximum min values as before. Okay, so again looking at our investigatory table, we have here x and sine x. What we're going to look at is what happens when we do sine of x minus 45. Okay, so here, when x is 0, we're going to take away 45 from 0, which will take us to negative 45, which we don't have in our table, so I'm just going to miss out. I'm just going to miss that out just now. Okay, next step, I would put x in as 45. Well, 45 take away 45 of 0, and sine 0 we have here as 0. Same with 90. 90 take away 45 is 45, and I know here that sine 45 is 0.7. 135, when you take away 45 gives you 90. When you do sine of 90 it gives 1, and I'm hoping you can see exactly what's happening. All these numbers are moving across one place. Okay, so the next one's going to be 0.7, 0, negative 0.7, negative 1, and negative 0.7. So when we have x to the minus 45, sorry, that's rubbish. When we have x minus 45 inside the bracket with sine or cos, everything here moves 45 degrees to the right. Okay, so we're going to be looking for exactly the same shape. Everything, instead of starting at 0, it's just going to go at 45. Instead of going through 180, it's going to go 225, and somewhere over here at 405 is where it's going to end. So we've got, well, that's not bad actually. We've got the same graph but moved 45 degrees to the right. Okay, so sine of x minus 45 moves right 45 degrees. Now similarly, if we've got x plus 45, I'll do this in blue. When I do 0 and 45, I get 45, so sine of 45 is 0.7. Sine of 45 add 45 is 90, so sine of 90 is 1. And then I'm hoping you can notice as well that all these are moving one place or 45 degrees to the left. Okay, so minus 1, then minus 0.70, and then I'll leave that one blank because it's out with our original table. Okay, so what you're seeing there is this point, instead of being at 0, is at minus 45 now. This point that was at 180 is now at 135, and this point was at 360, is now at 315. So we've got exactly the same graph, but it's moved left 45 degrees. So sine of x plus 45 moves left 45 degrees. Okay, so you need to see that when we put a number inside the brackets, added and subtracted, it moves side to side, the opposite way from what you'd expect. So if it's negative, it's going to come up the way, and if it's positive, it's going to go left. Okay, so that's our new rule, and that's the last rule we're going to look at here. Now, sketch the following graphs for 0 equals 360, so I'm looking to do the sketch for the whole thing between 0 and 360. I'm looking at cos of x minus 30. Now just quickly, I'm just going to draw a normal cos graph. So, looks like that. And that's 360, 270, 90, and 180. And that's 1 and minus 1. Now that minus 30 in here means that it's going to move to the right 30 degrees, or 30 places. So I'm still going to be 1 and minus 1, but the whole graph is moving to the right 30 degrees. So I'm going to have the same graph, but it's not going to go through 90 degrees, it's going to go through 120. It's not going to go through 270, it's going to go through 300. And that point there on the original graph, that maximum at 1360 is now going to be across at 30. Okay, so we're going to have something that looks like that. That minimum that was and I'm going to tidy that up in a second. That minimum that was at 180, negative 1, is moved across to 210, negative 1. And because it's moved right, this maximum here is now out with our 360, so we don't have to draw it. Okay, so it's not going to be as high there. But at the start, we know if it's moved to the right 30 degrees, that it's come from somewhere on the left hand side of that original graph. It goes back down. So some of that original drop again is moved into the range between 0 and 360. Okay, so it starts to become a little bit more complicated in that it's not just always looking like a cos and sine graph. It's just maybe skewed a bit to the right. Okay, so 2 sine of x plus 90. Well, let's just do our 2 sine x graph first. So we're looking at a sine x graph that goes to 360, 180, and 0, and it's 2 high and minus 2. The plus 90, that means that it's moving back 90 degrees. Okay, it's moving to the left. So this point here, which is at 91, it's going to move 90 degrees to the left and end up on the y-axis. Okay, so in our new graph, that top bit is going to start, oh, it's not 91, sorry, it's 92 because of the 2 sine x. That bit there is going to start up here. Okay, this 180 degrees, which cuts the x-axis, is going to move to the left, so that's moving up to 90 degrees. Okay, this minimum point up here, which is at 270 minus 2, when it moves to the left is going to become 180 and negative 2. So the halfway point is down at negative 2. And then that 360 is going to move to the left 90 degrees and it's going to end up at 270. Okay, so it's starting up here, coming down, hitting the negative, and then it's coming back up. And you can see actually that's a cos graph. Okay, you can see where if you're struggling to see the difference between sine and cos sometimes, they're very closely related, and when you move sine to the left 90 degrees, it actually becomes a cos graph. Okay, now that's what's happening with these graphs. If you put a number inside, added and subtracted, it moves side to side. Okay, a couple of more examples here. We've got a sine wave, or one of the options is a sine wave in this first one. Now it's one high and one low, so it's going to be just a 1 in the front, so we don't have to write anything. Okay, there's one wave that would be in 360, so it's just going to be sine x. But because it should start at 0 and it started at 10, it's moved 10 degrees to the right. Same with a 190, that should be 180, and at the end you can see it's not going through at 360. So 10 degrees to the right means that it's x minus 10. Okay, so that equation there is y is equal to sine, and then in brackets x minus 10. This one here is a cos wave, or one of the versions could be a cos wave, so it's cos. Okay, I can see here the amplitude is 5, so in front it's going to be 5. And then we know that cos should cut here at 90 degrees and 270, so it has been moved 15 degrees left. Okay, 90 down to 75 is 15, and 270 down to 255 is 15. So if it's moving to the left, it's moving back the way, so that means in the bracket it's going to be x plus, because it's 15 degrees, it's x plus 15. Okay, now again, quite similar to video 3, ones that don't tend to be examined to such a high level in terms of putting more rules in place. So I'm going to just leave that there. Now, I'm not going to leave you any questions. What I'm going to do is give you a quick recap. Okay, so when we put a number in front, like here with the A, what that does is it stretches my sine graph. So instead of the amplitude being 1, it'll be whatever that number is. So an A in front stretches it vertically. The B in the middle means that there is going to be B number of waves in 360. So one wave is going to be 360 divided by whatever B is. So if that was 4x, that means 4 waves in 360, which means one wave would be in 90. No number in front here, so it would just be 1 and minus 1. Okay, so the b in there, it squeezes it in. Okay, it squeezes it in by the factor of what's in front of the x. Sine x plus c, okay, that plus c at the end, that moves our graph up the way or down the way, depending if it's positive or negative. So our sine graph there means that it's moved up c places. And lastly, just what we've looked at there, the x minus d inside the bracket means it's moving back and forth the opposite way from what you'd expect. So the sine graph that would normally start at 0 is maybe moved back the way. Okay, so that moves d places. So we have to be careful that it goes in the opposite direction. Okay, now that is your summary. That is everything that's going to be in trig graphs. Come in, do some work. Any questions, give us a shout.